Organic chemistry basically is most of chemistry in general. There's something like over 20 million known compounds, and most of them, by all means, are based on carbon, all right? And organic chemicals are basically compounds based on carbon, and there's a lot of them around us. So my beloved caffeine, vitamin C, whole aspirin, all these kind of things and stuff are basically organic chemistry. Now, carbon is, as we saw in the last couple chapters, limited to 4 bonds around it, the octet rule, all right? It's never going to have more than 5. So we won't see like trigonal bipyramid and octahedral in this chapter, but we are going to see a lot of tetrahedral, trigonal planar, that kind of stuff. Most of organic chemicals then have carbon and hydrogen. A lot of them have oxygen as well, nitrogen sometimes sulfur and stuff. And there's a whole bunch of variety of compounds. And on this slide, you're seeing some of the possibilities. The animation there in the middle right is benzene. Benzene is a truly unique compound compared to the stuff we've seen so far, and we'll talk more about what it is. The lower right corner there, that's called propellerine. You can see it kind of looks like a propeller and stuff like that. So that's kind of interesting. And the rotating molecule in the lower left, that's actually propane. So if you've ever had a barbecue, you're probably using propane for your barbecue. Lots and lots of examples of these things. In organic chemistry, there's 2 main areas that people focus on in the major level course. And remember that this is a year-long course, all right, in the after Chem 223. So we're just going to barely dip our toe into this area and see what's going on. But anyway, when you think about organic chemistry, there's 2 main areas. Nomenclature is the big part. And nomenclature, like we saw in Chem 221, is just being able to name the compounds. So nomenclature of organic chemistry is going to be a big part of organic chemistry. You have to know what you're talking about, know which chemical to ask for, stuff like that. The other part of organic chemistry that's big is the reactivity. Like, what do you do with the compounds once you've made them? How do you make the compounds? Stuff like that. And those are really good. So in this class, in Chem 222, we're going to focus more on the nomenclature than anything else. So I want you to know the names. So know, again, like I said earlier, that an alkane is different than an alkene, stuff like that. But I will show a couple of examples of reactivity just so you kind of get a feel for the things that are out there. And then in the real organic chemistry year-long class, you'll go into a lot more detail about how the chemicals react, how you make them, stuff like that. When it comes to the naming of organic chemistry, you must start at what's called the alkyl groups. And alkyl groups are like building blocks for making organic chemistry compounds. Alkyl groups are not compounds by themselves. You have to add something to them to make them a compound. But these alkyl groups are in everything, and a lot of the naming we're going to do is based on the alkyl group. So I do encourage you to pay attention. One we've seen a little bit already in these lectures anyway, is the methyl group. Now, a methyl group is a tetrahedral sp3 carbon with 3 hydrogens connected to it. So if you think about what that is, tetrahedral means 4 bonds. CH3 has 3 bonds to hydrogen, but there's like 1 bond left over. So you can imagine then that I could draw here a CH3, and there would be 3 H's, but there'd be something else. And this something else, you can add different pieces to it to make it a compound. CH3 by itself is not a compound. That carbon needs 4 bonds. It needs an octet around it. But you could have a hydrogen next to it, or you could put a chlorine there, or an oxygen, stuff like that. So a methyl group is the simplest of the alkyl groups, and we're going to talk about it a lot. And a methyl group is just 1 sp3 tetrahedral carbon. The second alkyl group that we'll run into a lot is called an ethyl group. Now, an ethyl group is nothing more than a methyl group with a second tetrahedral carbon. So let me erase that question mark I put up there for the methyl group. And an ethyl group is nothing more than another tetrahedral carbon connected to the methyl group. So just like the methyl group, an ethyl group is not a compound unto itself. That should be a hydrogen. Sorry, that's that's really sloppy. There's something else that has to go there to make it a compound, and you could put a hydrogen there, oxygen, nitrogen, whatever. So an ethyl group is just a building block of organic chemistry. Ethyl has 2 carbons, methyl has just 1. Propyl is the next of the alkyl groups. So if you put another tetrahedral carbon on the end of the ethyl group, where my question mark is, that would then essentially build you a propyl group. You'd still have another spot left over to put another group in there, and a propyl group is not, again, a compound. It's just a building block. Notice, though, how earlier I mentioned propane. Propane is related to propyl group, and we'll talk about that in a little bit. Butyl is 4 carbons, and again, all those carbons are tetrahedral, sp3, so you'd have something else on the end of the butyl group there to make it a compound. A butyl group is not a compound unto itself. Then there's also pentyl, hexyl, heptyl, octyl, which are 5, 6, 7, and 8 carbons. Yes, it goes beyond octyl. There's nonyl and decyl, which are 9 and 10, etc., etc. We're going to see that using an R is a helpful term here. And R just means you have some generic alkyl group connected to it. So if you see a big R, it just means you could have a methyl group, you could have an ethyl group, all kinds of stuff. Alkyl groups may be combined with other elements or other alkyl groups to give classes of compounds. So we're going to see that organic chemistry is split into different types of compounds or classes, all right? The alkyl groups are the building block. So you could put 2 methyls together, for example, or you could put a methyl and an ethyl, or a propyl and a butyl, or anything like that. You could also combine them with hydrogen and chlorine and a whole bunch of different things. At this point, I'd like to advertise the handout listed at the bottom, the Organic Chemistry Nomenclature Guide. This is in the companion. It's also on the website. But this lists many of the beginning alkyl groups in greater detail. And also there's a whole list of the different families or classes of compounds that we're going to be seeing in this section. So I do recommend that you check out that handout to get a better idea as to what's going on here. So the simplest of the classes of organic chemicals is called an alkane. And an alkane is when you take a generic alkyl group R and you put a hydrogen on the end of it. So literally, like we said, all of those groups we saw, the alkyl groups, they aren't compounds, but if you put a hydrogen on the end, then your carbon has 4 bonds around it, it's got its octet, and you're going to make a compound. So all of the alkanes are just alkyl groups with a hydrogen on the end of it. There's a generic Alkane formula. You can see it there. It's CnH2n plus 2. So for every n hydrogens, you're going to have 2n plus 2 hydrogens. And to name an alkane, you take the alkyl group, you subtract the YL, and you add ANE to the end of it. So let's look at the simplest alkane, which is methane. Methane comes from a methyl group. So if you take the YL off the methyl, you get meth, and it's not that kind of meth, all right? It's just a meth group. Anyway, add ANE to it, methane, that's where the name comes from. And notice the formula. For every n carbons, you have 2n plus 2 hydrogens. So we have 1 carbon, so 2 times 1 plus 2 would be 4 hydrogens. Methane is CH4. Methane is the main ingredient in natural gas. So if your house or home is heated by natural gas, then you've certainly used methane and stuff for heating, which is really cool. So again, methyl group plus hydrogen makes an alkane. Methyl minus YL plus ANE is methane, and the formula CnH2n plus 2. But this is just a class or family of compounds, and this R was methyl, but you don't have to use methyl. You could use ethyl. So ethyl minus YL plus ANE would be ethane, and an ethyl group plus a hydrogen would be the formula for ethane. So N carbons here is 2 because there's 2 carbons. 2 times 2 plus 2 is 6. C2H6 is the formula, and this is ethane. Notice again that this is all tetrahedral, sp3, all the bond angles are 109, etc., etc. Ethane is a small component, as I understand, of natural gas. Most of it is methane, but there's a little ethane in there as well. Propane is a propyl group plus hydrogen. So you can see how propyl ends up as propane if you add a hydrogen to it. So the propyl group was CH3CH2CH2, put a hydrogen on the end, everything's tetrahedral, sp3, 109 degrees, etc., etc. Propane is this one. Propane is the main ingredient a lot of times in barbecues. If you've used a barbecue, it's probably propane, which is cool. And again, you can see the formula. But again, why stop there? Next one, butane. Butane is a butyl group with 4 carbons with a hydrogen on the end. In this case, N of 4, which is 4 carbons. So 4 times 2 plus 2, 10 hydrogens. You've got the thing. All right. If you hear the term saturated hydrocarbons, that just means that every position around the carbon is saturated with hydrogen, like you only have hydrogen. You don't have any double bonds, we'll see, or you don't have an oxygen or something like that. So anyway, all the ones so far have been just an alkyl group with a hydrogen on the end of it, and you can see how to name them. Which of the following could be an alkane? And this is the kind of question you might see. And you can see there's a whole bunch of different formulas there. Well, the way to answer this is to go back to the generic alkane formula. And if you have an alkane, then for every N carbons, you're going to have 2N plus 2 hydrogens. So if you look at number 1 right there, N would be 2. 2 times 2 plus 2, 6 is certainly not 4, so number 1 is not an alkane. Notice that number 1 and number 2 have a CnH2n relationship. So for every N carbons, you have 2 N hydrogens, so neither one of those would be right. If you go to number 3, 14 is N, so 14 times 2, 28 plus 2, aha, H30. So number 3 sounds like it's an alkane. Number 4, certainly not. You don't have anywhere near enough hydrogens for that molecule. And the last one has oxygen, so that's not an alkane. We'll talk about oxygen later, but it's certainly not an alkane. Alkanes have just carbon and hydrogen. So only number 3 there is going to be an alkane, C14H30. The other ones are different kind of structures, and we'll look at some of those here in a little bit.